We are currently in a condensed lesson, connecting with the vastness of our universe. Andromeda, a galaxy with hundreds of billions of stars, is our closest galactic neighbor. It is speculated that, in around 4 billion years, the Andromeda Galaxy will collide with our Milky Way. However, a surprising signal has been sent back to Earth by the James Webb Space Telescope, indicating that the collision may occur much sooner than expected. After a century of doubts, the data from the James Webb Telescope has revolutionized our understanding of Andromeda, revealing unexpected and unsettling insights about its true nature. This discovery has sparked a wave of excitement and speculation within the scientific community. Is this a response to our attempts at interstellar communication, or does it signal a monumental event that is still unknown? What will happen when Andromeda collides with Earth in the Milky Way? Join us as we explore the explanation for the disturbing signal detected by the James Webb Space Telescope from the Andromeda Galaxy. Our galaxy, the Milky Way, belongs to the local group of galaxies and is a spiral galaxy. To find it, look up at the night sky toward the star Sagittarius, where its galactic center is faintly visible. All stars within the Milky Way are part of this galaxy and are visible to the naked eye from Earth. The Milky Way's rotational speed is faster than many other galaxies, and despite there being billions of galaxies in the universe, it took humanity a long time to comprehend its true nature due to limited scientific tools at the time. Early civilizations, such as the Greeks, noted the Milky Way but only realized its true structure after the invention of the telescope. In the 17th century, astronomers like Galileo were able to observe the Milky Way as being made up of countless stars, a crucial step in understanding the formation of our galaxy. In the early 20th century, the debate about whether the Milky Way was the entire universe or just one of many galaxies was a major topic of discussion. Harlow Shapley argued that the Milky Way was the entire universe, while Heber Curtis proposed that the universe consisted of many galaxies like the Milky Way. This debate was settled by Edwin Hubble in the 1920s when he observed variable stars in the Andromeda Galaxy, proving it was an independent galaxy outside the Milky Way. Hubble's work on Andromeda also led to one of the most significant discoveries in modern astronomy: the expansion of the universe. By studying the redshift of light from the Andromeda Galaxy, Hubble demonstrated that the universe is expanding, with galaxies moving away from each other, which formed the basis of the Big Bang theory. However, Hubble was not the first to observe Andromeda. The Persian astronomer Abd al-Rahman al-Sufi mentioned Andromeda as the little cloud in his Book of Fixed Stars in 964. It was the first known observation of Andromeda with the naked eye before telescopes were invented. It was only much later that the full nature of the Andromeda Galaxy was understood. For a long time, astronomers believed Andromeda to be much larger than the Milky Way, and from our perspective on Earth, it's easy to assume that nothing could be larger than it. But this was a misconception. Recent research has led to a reassessment of these beliefs, confirming that Andromeda is about 10 billion years old, placing it in the early universe. Its age suggests a long and complex history of development. The Milky Way is about 100,000 light-years across, while Andromeda spans 220,000 light-years, making it twice as large as our galaxy. While the Milky Way contains around 250 to 400 billion stars, Andromeda is home to approximately 1 trillion stars. Despite its tranquil appearance, astronomers have discovered a violent past and future for Andromeda. The dynamic galactic center of Andromeda, a region known as the active galactic nucleus (AGN), is one of the most fascinating aspects of the galaxy. This area is characterized by powerful energy emissions, including X-rays and radio waves, and is powered by a supermassive black hole at the galaxy's center. These black holes are dense regions of space with immense mass compacted into a small volume, and Andromeda's black hole is estimated to be between 110 and 230 million times more massive than our Sun. The intense gravitational interactions between this supermassive black hole and the nearby stars are responsible for the activity in Andromeda's galactic center. These stars orbit the black hole in an eccentric manner, similar to how planets orbit our Sun. The stars reach their closest approach to the black hole at a specific orbital point called periapsis, where the gravitational forces are strongest. One interesting theory about Andromeda's formation is that it was shaped by the merging of smaller protogalaxies. This suggests that over billions of years, smaller galaxies collided and merged due to gravity, eventually forming the massive Andromeda Galaxy we see today. Galactic mergers like this are common events in the universe, contributing to the growth and evolution of galaxies. However, these processes happen at such a slow pace that we cannot observe them in real time until significant progress has been made. Despite its fascinating qualities, recent observations by the James Webb Space Telescope have sparked speculation among astronomers that Andromeda might be undergoing a dramatic transformation. The signal detected suggests that Andromeda may be shifting from a spiral galaxy to a ring galaxy, a rare and intriguing galaxy type characterized by blue, massive newborn stars in its rings. The central region of Andromeda contains very little luminous matter, which could explain this transformation. Ring galaxies stand out due to these unique features, and the James Webb Space Telescope has also noted that the histories of the Milky Way and Andromeda are similar. Both galaxies share a common expansion event that influences their internal structures. Experts believe that the Milky Way and Andromeda will eventually merge to form a new, massive galaxy. Currently, Andromeda is traveling toward the Milky Way at approximately 200 kilometers per second, and this collision is expected to occur in the next 4 to 5 billion years. However, the recent findings from the James Webb Space Telescope suggest that this cosmic collision may happen much sooner than previously thought. How could this be? One possible explanation is that the Milky Way and Andromeda became gravitationally bound to each other long before dark energy began to dominate the expansion of the universe. As a result, the two galaxies will eventually merge, creating a new, larger galaxy. Monikers like Mila or Gentle Roma have been used, but despite these charming names, the consequences of a merger between these two cosmic structures would be catastrophic for humanity's progress. The immense gravitational forces of the two galaxies would distort each other's shapes as they draw closer. However, since these galaxies are sufficiently distant from each other in the vastness of space, it is unlikely that they will collide anytime soon. For instance, Proxima Centauri, the closest star to the Sun, is about 4.2 light-years away. While stars are more densely packed in the centers of galaxies, the average distance between stars is still around 100 billion miles. Therefore, it's improbable that two stars from the merging galaxies would directly affect each other. Still, the scenario changes when considering the central supermassive black holes of both the Andromeda and Milky Way galaxies. Over millions of years, these black holes will inevitably spiral toward one another and eventually merge. As they do, they will produce powerful gravitational waves, which are ripples in the fabric of spacetime caused by the most extreme and violent events in the universe. These waves were first predicted by Albert Einstein in 1916 as part of his general theory of relativity, and have since opened new avenues for studying the cosmos. As the black holes draw nearer, their gravitational pull will warp spacetime, creating a spiraling effect. The waves will intensify as the black holes approach, sending out ripples at the speed of light. When the black holes are within 1 light-year of each other, the gravitational waves will become incredibly strong, causing them to lose orbital energy and spiral toward one another more rapidly. Eventually, the black holes will merge, releasing an unprecedented amount of energy, surpassing the combined energy of all the stars in the observable universe. This merger will not only produce gravitational waves but will also emit electromagnetic radiation across the spectrum, including X-rays and gamma rays. The merger will likely result in a single, even more massive black hole, surrounded by the remnants of the accretion disk, with the possibility of high-energy particles being ejected at near-light speeds. This process could form a newly active supermassive black hole at the center of the merged galaxy, known as an active galactic nucleus, AGN. AGNs are some of the most luminous objects in the universe, and their radiation could significantly impact star formation and other galactic processes. The energy from the AGN could blow gas out of the galaxy, potentially halting star formation and altering the overall evolution of the newly formed galaxy. Over time, the AGN will likely lose power as it consumes all the available material, eventually becoming less active. Nevertheless, the merger of these supermassive black holes and the resulting AGN activity would leave a lasting imprint on the structure and evolution of the galaxy. As for the fate of our own solar system, current estimates suggest there is a 50% chance that the Sun will be displaced farther from the center of the newly merged galaxy. Our solar system resides in the Orion Spur, a minor arm of the Milky Way, and could be pushed out into a more distant region during the galactic merger. There is also a 12% chance that our solar system could be ejected entirely from the new galaxy. As for life on Earth, it's unlikely that it will survive the merger. In about 7.5 billion years, the Sun will expand into a red giant, potentially engulfing the Earth. However, this process will begin much sooner, with the Sun's brightness gradually increasing over the next 4 billion years. As the Sun's radiation intensifies, Earth's surface temperature will rise, possibly triggering a runaway greenhouse effect similar to what is currently happening on Venus. Consequently, life as we know it may not survive the galactic merger, although some humans might have already colonized other planets or even left the solar system by that point. While the merger of Andromeda and the Milky Way could change the fate of our solar system, the possibility of humanity surviving and even thriving in a new galactic environment may still exist, albeit from a very different perspective.